This is Chapter 15, Schoology problem number 6, probably the toughest of the Schoology problems because there's a lot going on here. So they give us this probability model to show the amount of winnings earned at a carnival game for the Houston Rodeo for shooting darts at different colors of balloons. So first you need to know how to interpret this thing here. That means there is a 45% chance you're going to lose $2. There's a 30% chance you're going to gain $1. You're going to win $1. There's a 20% chance you're going to win $50, and there's a 5% chance you're going to win $5. So let's go ahead and put this in the Staplet first to get started. So I'm going to bring up Staplet here. And we're going to choose discrete random, and we're going to put in, it's a carnival game, game. And there were 4 different possible outcomes for us here, so we're going to put 4 of those. There's a chance we're going to lose $2, negative $2. That had a 45% chance, 0.45. And there's a chance we're going to gain $1. That one has a 30% chance, 0.30. Chance we're going to gain $50. Oops, $50, my bad, $50. And that one was a 20% chance. So 20% chance to win $50 just seems like a pretty good game we got going on here. And then a 5% chance to win $5. Not sure why a game would be set up to be more likely to win 50 than to win 5, but you know, got to go with what they give us on the problem here. So here's our distribution. And here is our mean and standard deviation. The mean, on average, we're going to win $9.65, it looks like. Give or take $20.25, 0.254. I expected that kind of deviation because we got this 50 over here bringing the standard deviation up, right? It's way away from the mean of the 9 right here. And that's what's causing the standard deviation to be so high, because there's a decent chance you're going to win $50, or you might even lose some money. And that's if those have a big difference, right? There's a big difference between those outcomes. So that is our mean and standard deviation. So my mean is 9.65, and my standard deviation is 20.254. All right, so suppose all of the outcomes are doubled. So if we doubled all of the outcomes right here, what would it do to the mean? So the mean of 2 times x, we're basically doubling it, right? If we double all the outcome, it's going to double the expected value, so it should be 9.65 times 2. And so get a calculator and do 9.65 times 2. 9.65 times 2. And you get 19.3, $19.30. So 19.3 would be the answer for B. And the standard deviation on this one, we're actually doubling the standard deviation as well, right? Since you're doubling the amounts, you're just doubling the standard deviation. So the standard deviation of 2 times x would just be 20.254 times 2. And 20.254 times 2 remember that, 20.254 times 2. 20.254 times 2. I get 40.508. And so I get 40.508 is the standard deviation on this one, and this one is the mean. So that should be B if I just double the amounts. So what happens if the outcomes increase by $5? When you increase all the outcomes by $5, it's just going to make x plus 5 means the mean goes up by $5. So 9.65 plus 5 which is 14.65. So 1465 for the mean. For the standard deviation, remember, just adding a number to all of them does not change the standard deviation at all, so it will remain the same. It will remain 20.254. So that will remain the same if you just add $5 to each of them. Now, playing the game 8 times, the mean of x 8 times would just be 9.65 times 8. So 9.65 times 8 would be my mean, because I'm averaging 965 per time, and then 8 times that I'm going to play. So it'd be 9.65 times 8. 77.2 would be my answer on that one. 77.2 would be my mean. Now my standard deviation for x 8 times would be the square root of x squared plus x squared plus x squared 8 times, right? Which another way you can write that is 8 times x squared. So you take your x squared and multiply it by 8. So it would be 20.254 squared times 8, and square root all of that. So anytime you just do the same event multiple times, you square that standard deviation and then multiply by the number of times that you do it. Instead of just adding 20.54 8 times, you just multiply by 8, which is the same thing. You can write it out 8 times if you want to in your calculator, but I would not advise that. So it is 20.254. Oops, we need to square root everything. The square root of 20.254 squared times 8. And I get 57.287. And so I get 57.287 as my new standard deviation. And that is D. All right, that should be all for number 6 on our Schoology assignment.